Okay, here is my homework help video for Monday's transformation tasks homework. I'm going to try to go through this relatively quickly because it's because I have a lot to do and I don't want to keep you guys watching this forever. So the first part says go ahead and graph the shape. It says the triangle and these are the vertices. I didn't write in all the locations because it's going to get really busy in here and I don't want to try to do that. Step 1 says reflection over the x-axis. So the x-axis is this line right here. I always draw in a line of reflection. Please do that and you will have a far easier time. So since the shape straddles the x-axis, we need to essentially like flip it over. So it's almost going to stay in the same place and it's just going to kind of turn over. If you can imagine this triangle right here, we're just switching places like this. So the way you actually do it is you take the original points and you count the distance to the line of reflection, and then you count the distance, whatever the amount of units you counted, you count that distance again past the line of reflection. So if I go 1, 2 to the line of reflection, then I go 1, 2 past it. And you can see it lands right there. Mark it A prime. B goes the other direction, so it goes 1, 2, 3 to the line of reflection and 1, 2, 3 past. C goes 1, 2 to the line of reflection and 1, 2 past. Mark it C prime. Use your straight edge. Please use a straight edge. Thank you. And draw in your new triangle. Also notice how I'm using a couple different colors. That's kind of helpful. Okay, so there's your reflected image. It's perfectly symmetrical across this line of reflection. Then it says to fill in these vertices or fill in these locations, and I'll do that in a minute. So rotation 90-degree clockwise about the origin. Clockwise, like a clock, goes like this. So any point in this axis will end up in this axis. Any point in this axis will end up in this axis. I'm going to switch to green for this. So let's just start with A and go on. I'm going to use the Mrs. Reynolds method, which is to count up the axis and into the quadrant. So I go 1, 2 up the axis and 1, 2 into the quadrant. Spinning to the next location, I go 1, 2 up the axis and 1, 2 into the quadrant. So this is going to be A double prime also. This location right here. Then I'm going to do B, and B is going to go, I go 1, 2, 3 up the axis and 1, 2 into the quadrant. So go to my next quadrant, 1, 2, 3, and 1, 2. B double prime. And then C, I go 1, 2, 3, 4 up the axis and 1, 2 into the quadrant. So I have to go 1, 2, 3, 4, and 1, 2. And I don't know if you can see, but I've actually already done this, so I know it seems like I'm going exceptionally fast, but I have already marked these off ahead of time so that I would hopefully not make too many mistakes and confuse everybody. Okay, and there you go. So you can see your shape that looked like this has rotated 90 degrees to look like this. If we use patty paper, that'd be absolutely fine. I love patty paper. And then a translation, 3 units down and 2 units to the left. So I'm going to go down 3 and left 2, just to keep, this helps me keep my mind around what I'm doing. I'll get another color here. No, actually I'll make this one the Batman of them. Okay, so down 3 and over 2. I was on green or double prime last, so I'll have to start there. So 1, 2, 3 down and 1, 2 over. This is going to be C triple prime. And then let's see, starting at A double prime, I go 1, 2, 3 down, and 1, 2 over. That's going to be my A triple prime. And then 1, 2, 3. Oh, sorry, 1, 2, 3, and 1, 2 over. This is my B triple prime. Okay, let's go ahead and draw that in. And we are done with this part of it, except writing in the locations. I'm going to do that in a minute. And I just want to talk about question C. Is this triangle congruent to the original triangle? So this is the newest one, and the original is that dark blue one. So the definition I have is a shape is congruent after a rigid motion, translation, rotation, or reflection, because it is the same in angles and side lengths. So does that make it congruent? These are all rigid motions. I had no dilations, so yes. Boom, it is congruent. Yay! And we are done.